Can everyone in the back hear me okay? Yeah, okay, great. Hi, I'm Sean. Yeah, I'm here to talk about Sensu 2.0 and Chef and how it can bring delightful monitoring. So I'm just curious, actually, who in this room, raise your hand if you're familiar with Sensu or use Sensu. All right, my people, awesome. So my name's Sean Porter. I'm the original author of the Sensu project and CTO for Sensu Inc. I'm at PorterTech on Twitter and many other social networks. So hit me up there if you have questions. So as technologists, we all love to solve our problems with technology. I mean, that's what we do. That's our job. Funny enough, though, we create new problems with that technology, and it's this vicious cycle. And I think we all understand this problem. One perfect example of this is starting with of how infrastructure is like evolved over time. So if we think of bare metal, that's the best illustration ever. You have a host, and your host had one or more applications that run on it, right? It's very simple. We were usually talking about single digit, maybe 100, maybe into the thousands of these bare metal hosts. And then we decided to want some more isolation for our applications. We wanted to get more resource utilization on those bare metal resources, so we added VMs, right? Some way of encapsulating one or more apps. We took it a step further and we're like, okay, we want containers on top of our VMs so that we can absolutely isolate the runtime for those apps. And what's happened is over time, in order to solve our previous problems and be able to move faster, we've increased the amount of complexity in the infrastructure. Growth looks pretty linear. I wouldn't say it's like going crazy, but not only are things getting more complicated, the number of things we have to manage and monitor is ever increasing. To make this problem worse, our apps can span any number of these technologies. I mean, like new things are shiny and fleeting and exciting, but old is forever. And the reality of when you add on to new technologies, those components are going to span all the way back, probably to those bare metal servers in a closet somewhere. And also, as an organization changes and the technology evolves, the number of people involved in it grows. And then we naturally get separate teams. And everyone has their own different opinions on how they want to manage and monitor those things. So Chef comes along as a tool that allows you to manage these ever-growing in complexity environments, these heterogeneous environments, and allows you to move faster with it. Sensu is really the monitoring tool to solve this problem from that angle. So it's an open source monitoring tool that you run on your infrastructure, and it lets you know the health of that infrastructure. So I'm just going to talk about design a little bit so that you all have an idea of how Sensu works. So you have a Sensu agent that you run on your infrastructure that you want to monitor, and then you have a backend that's responsible for processing the data that comes out of those agents. When an agent starts up, it makes an initial connection to the backend, and then it says, hello, I'm here, here's some information about me. This is how Sensu does auto-discovery. What's also cool about Sensu is that it can say goodbye, graceful shutdown. It can say, hey, I'm going to be decommissioned now, don't worry about me anymore, don't page people in the middle of the night because I'm no longer doing this responsibility. That's a key thing. The agent itself has a number of different APIs so that you can instrument your applications and your scripts and input that data into the agent, and then it goes through into the Sensu backend. What Sensu is also really good for is execution scheduling for service checks. So if you're familiar with like Nagios, the Icingas, the Zabbix of the world, where you run these commands, that's what Sensu is capable of doing. It does it in a very unique way. So how Sensu works and how it targets hosts for these service checks is through what are called subscriptions. So you have collections of machines. If you're a Chef user, which I'm sure most of you are, this is a perfect parallel with what your run list or your roles can look like, because you're saying this is a web server, this is a database server. Same thing can be when you monitor, you can say, I want to monitor my app servers, I want to monitor my database servers. So in this case, this example, a check request goes out to the Linux subscription, and all my Linux machines are going to concurrently run this. Or it gives you a unique opportunity to do some fun things like snapshotting across a whole group of machines. So in this example, I publish a check result to the production subscription. Only these two agents running on these systems are within that, so they execute the check. The one in dev did not. Sensu also allows you to do round-robin scheduling, so you can say, I just need a host that is within the subscription to run this check. This is particularly useful if you want to say, I need something to monitor my edge router. So this is how Sensu can solve that problem. HA is solved through this ability to run more than one Sensu backend process. And what happens is the agent will randomly connect to one, or you can put a load balancer in front of it. And in the event of a failure, it'll simply go to the next backend. Communication between the agent and the backend is done through what are referred to as events. Events kind of look, well, they look like this. So they have a timestamp. They have an entity which is describing something, whether it be a bare metal host, a VM, a container, an application. Then you have a check, those are your service checks, and then metrics for payload for telemetry data. Where Sensu's secret sauce is in the backend. So when these events come back from those agents, from those executions, or API input, it goes into the backend. And then we store some data about it and provide an API to give you access to that data and provide third-party integrations. And then we have this super sweet pipeline of filters, mutators, and handlers, really way of processing that data. So if a check came in, it can actually be handled by more than one event handler at a time. Some good examples of this would be, if you want to take metric data from that check and send it into InfluxDB. If you want to notify your teams about a potential issue that's rising, notify them in Slack. If you want to wake somebody at night, use PagerDuty. Or if you want to archive that data for future reporting and auditing, send it to something like a Graylog or Elk or Splunk stack. So Sensu really allows you to glue everything together. It's this backbone of the monitoring and telemetry solution. It kind of sits in there, pulls everything through, and then allows you to do interesting things with that data. I mean, the opportunities are endless. You can pretty much write a plugin to do anything with Sensu's data and add support for your own services. So this is something very different for a monitoring tool. A lot of stuff tries to be the monolith to control the whole thing. Sensu is all about this extensibility and composability. So configuration in Sensu 2.0 is all done through the backend REST API. And we have this really cool RBAC model for multi-tenancy. So it allows you to have a single Sensu deployment. How are we on time, actually? Sweet. And you can cut up into multiple segments. You can say, this team, here's your own slice of Sensu. You can create all the checks you want for your infrastructure. This team, you get your own slice of Sensu. So that's kind of how 2.0 is allowing you to have these multi-tenant environments. The backend embeds etcd for configuration. This is what handles our replication of configuration and state between the backend processes. We try to do as little coordination as possible because we want to eliminate most of the distributed system problems that we can. Configuration UI can be done through Sensu Cuddle CLI tool. If you saw my demo yesterday, you would have seen me using this with my Kubernetes deployment. You can also do some config through the dashboard, which is going to get better. And then what we're actually here to talk about is Chef. So the cookbook, there's a next-gen cookbook called the Sensu Go Chef Cookbook. The name is likely to change. It's not currently in the supermarket, but you can find it on GitHub at Sensu/Sensu Go Chef. It has a number of custom resources. So this is really following that library cookbook pattern. It's all about the components you need to stand up the Sensu services as well as configure these objects. So one of them is the Sensu backend. This one's creating one called ChefConf. And we're doing the most recent release of 2.0, which is beta 1. And we're simply doing a little bit of configuration. This will stand up the process. This will get you the backend for processing, for agent connections, the API, the dashboard, the whole thing. That is, in effect, a whole Sensu deployment with one resource. The Sensu agent is what you would run on through your Chef cookbooks on your nodes that you want to monitor. So in this case, on my MySQL machine, I would use a Sensu agent resource that looks a little bit like this. So what I'm also saying here is if you see in the config, I've got organization Acme and environment production. So this box is part of that org and in that RBAC model. So that team is responsible for it. So this is really cool because if you're familiar with Sensu 1X right now, getting started, it takes a little bit longer. But the reality with 2 of these resources, we were able to do a full working Sensu 2.0 deployment, which is fairly exciting. It's kind of a big deal. Yeah, we're really excited about it. And the Sensu Cuddle command, the CLI tool, has its own Chef resource as well. And this is actually how the Chef Cookbook interacts with the Sensu backend API is through this tool. That gives us this easy ability to upgrade this tool as the Sensu version changes and if there's any changes in the API. And the Chef Cookbook will simply continue to work as if nothing has changed. So there's really 3 methods of data collection with Sensu. First being service checks, which are just commands that you run and that output some interesting information to standard out and exit status for, indicate severity. So an old, like a 20-year-old plugin called Check MySQL, here's somewhat of a human readable message and some interesting data, and it's okay. In the event of it not being able to connect, it does exit to. This tells us it's not running. We probably want to be alerted by this. So in the Sensu event, it looks like this. So you get your check command output and the status. And what's great about service checks is it allows us to encompass a number of symptoms around things. So we can take our domain-specific knowledge around MySQL, for example, and encode it and bake it into this plugin so it understands the common failure situations. Sensu cares about this transition between when it's passing and failing. That's probably when you want to be alerted, whether it's a new issue or it's resolving. So with the Chef Cookbook, there's a Sensu check resource, and that's how I configure my checks. And right now I'm saying, go create this check via the backend API that's going to target my MySQL boxes. What's cool about this, these plugins too, is they have this format called Nagios perf data. And Sensu 2.0 gives this the ability for it to extract that data and transform it into the Sensu 2.0 metric format. So here we are, these 2 attributes you can do. It says Nagios perf data. Is pretty rad. So what it does is it creates this in the event data. So it extracts it with tag support and some pretty cool things. So one problem with service checks with config management and monitoring tools is usually like, run this check, and it's like, I don't have that script. That's a big problem. So 2.0 has this a concept called assets, which you can register web objects that can be tied to a check at runtime. So if I have a Sensu 2.0 plugin called MySQL Plugins, it's just a tar with a 512 sum, and then I can create that asset, and then I can tie it to my check. So now when I tell all the agents that are subscribed to MySQL to run this check, they will actually fetch that object, verify its integrity, expand it into a sandbox, add that to the check run path, and execute the check, which is pretty rad. So I can have Chef effectively stand up Nginx, be my asset server, and then I can just ad hoc create these checks that rely on those assets, and everything just happens as needed. So service checks are extremely simple. They're very accessible. Anyone that can write a script or command that outputs a standard out and an exit status can write a plugin for service checks. So accessibility is great. Shareability, I can just share that with you and you can apply it to your own infrastructure. And legacy. The Nagios project has been making these plugins for 2 decades. So we can leverage that. There's over 7,000 plugins. So the events API is another way. The agent and backend both exposes the same thing. Really what we can do is we can post through events and we can just create these arbitrary events. What's cool about this is we can also register entities with this. So if I have network gear, I can just post to this API and I can register components about my network gear or applications or function calls or even something on AWS Lambda. I can also instrument my backup scripts. This is incredibly useful. So if you want to know if your backup scripts are actually running and they're running on time, you can instrument them to output to this API. A TTL, that's 6 hours and seconds, by the way, I think. But what will happen here is if the backup script does not run every 6 hours, Sensu will notice and notify somebody. I mean, I bet you there's many of you that have backup scripts that aren't actually running right now that you think are running. And then metrics, you can just output telemetry there. Another API that's in the agent is statsd. It's a fantastic, simple protocol that gives you support for stats, gauges, counters. It looks like this, and it simply emits a UDP packet to that socket. What's cool about this is that you can instrument your applications with statsd libraries, and Sensu will just collect that, transform it into 2.0 format, and then you can send it through the Sensu event pipeline to send it to Influx, Graphite, OpenTSDB, and even Prometheus. So this is what that looks like when the statsd instrumentation works. So 3 methods, recap, service checks, the events API, and statsd. These are the 3 main ways of data collection. I mean, I'm the last of the day, so I can go over time. I'm still good, 6 minutes. Event processing, so doing things with our collected data that we got via those 3 different methods. So we're going to create a Sensu handler for Slack. So this is a type pipe, which means we execute a command, and we pass the event data via standard input to this command. This one will just notify using a webhook to a Slack channel and say, the system is down. Good reference. OK, and then filters. What I'm saying is this one only cares about incidents that aren't silenced. So in the event where something comes in and service check is exit status 2, that's what this handler cares about. In another case, I have my InfluxDB handler. This one only cares about metrics. So any event that specifies this handler that has metrics will go through this, and it'll get written into InfluxDB. So going full circle back to that check MySQL, I would actually configure 2 separate handlers here. I'd say handler Slack. So for my incidents, I'm going to tell people when MySQL isn't running or aren't within my set parameters. And then for the output data that I'm extracting from that perf data, I'm going to send it in InfluxDB. So this is incredibly exciting because if you're an organization that has a Nagios, for example, and all these plugins that are like writing to an RRD file with your very limited visualization, right? You can leverage that 20 years of plugins and extract that telemetry data and store it in a modern time series database like InfluxDB. So I mean, as that time goes on, as that complexity is increasing, Chef and Habitat are helping us manage our things to have that increased velocity. Sensu is really about allowing you to maintain the optimal visibility as you do that. It's uniquely architected for these ephemeral infrastructures, things that have a lot of components that come and go rapidly. And then it has that multi-tenancy RBAC model to allow you to slice and dice your Sensu install and grant people access to create change. One thing to mention is you can also choose to go the far end of the spectrum and only have a single RBAC user called Chef, and have Chef the only thing that's capable of managing your Sensu resources. And that's fine. But this also gives you the ability to go the other end of the spectrum, which is self-service to your developers around their applications. So Sensu and Chef, they naturally go together really well. I mean, this is more peanut butter and jelly to be going with that. And I realized I think I did it on time. And thank you all for coming and listening to my talk. So I've got actually 3 minutes left. So if anyone has any questions, please raise your hand. We'll get you a mic, and you can ask away.
Yeah, 3 minutes. I got to run.
So how is Sensu 2.0 different than Sensu 1.x with Uchiwa?
So Sensu 2.0, so 1.x. Yeah, 1.x relies on a central transport. By default, that's RabbitMQ. So in order to run Sensu, you also have some knowledge of how to deploy and use RabbitMQ. And then 1.x also stores data within Redis, so you have to do the same for that service. And there's a few bit more pieces in 1.x, as well as all configuration was done via config files. So in 2.0, what we've done is removed all the sources of friction that we've seen rise up over the last few years. So 2.0 does not need a separate transport. It does not need a separate database. And configuration is all done via the API to just open up things to more workflows. So it's all about making it easier, all about making it more lightweight and easier to maintain going forward.
When you're going to offer Sensu on Kubernetes, Sensu 2.0 especially, as a sidecar proxy, 2 questions. One is, like, will it be available at just like own operator or something like that, or maybe you're going to use some Habitat operator to deploy Sensu? Like, what's your thought on that?
Yeah, so on my demo yesterday, I actually demonstrated 2.0 on Kubernetes, and it was using the sidecar and daemon set pattern, which seems to be a common way of approaching the problem. To make things easier, we do have plans to have a Kubernetes operator to make the back-end scaling and deployment even easier on that platform. As well as tomorrow during the hack session, we're going to create some hab packages for Sensu for both the agent and the backend component. So I mean, anything we can do to make it more native for those platforms, we're going to be doing.
You mentioned the assets. Is that a specific format of a tarball? Is it just a tar.gz? Is there a defined data directory structure for that?
Yeah, so it's as we tried to avoid calling it a package because we don't need more packages. It is a directory that has either bin, user, lib. Like the only mandatory one is bin, and you can just drop binaries right in that directory, and then you create either tar or tar.gz of that. And I believe you can even use zip if you so choose.
All right, I think we're at time, so let's give Sean another hand.
Great, thank you.